Assalamualaikum and a very good day. My name is Lailatul Aliyah Binti Kalim with matrix number 2020870886.
My name is Nabihah Binti Yusnizam, matrix number 2020852784.
My name is Syafika Binti Hamid. My number ID is 2020876974. Related rate. What is related rate? Related rate involves two or more variables that change at the same time or possibly at different times. In a related rate of application, we try to find the rate at which one quantity is changing by relating it to other quantity with known rates of change. The rate of change usually expressed with respect of time. Related rate, rate of change. The step for solving related rate problems. Okay, first you need to draw a diagram if possible, and then the next step you have to label the quantity mentioned in the questions, and then the third one you have to find the equation that relate the quantity whose rate of change is to be found to the quantity whose rate of change are known. And the next step, you have to use the chain rule or implicit differentiation to differentiate both sides of the equation with respect to time, which is t. Okay, the last step for solving related rate problems is you have to solve the derivative that will give the unknown rate of change. That was all the steps for solving related rate problem. What is differentiation? Differentiation is a process to find the derivative or rate of change of a function. Okay, when do we apply differentiation? We apply differentiation when we want to differentiate functions and solve the differentiation problems. Okay, to differentiate a given function can be solved by using three techniques of differentiation. First, derivative of sum and difference. Second, derivative of product rule, or also known as the product rule. And then the third one would be derivative of rational function, or also known as the quotient rule. Okay, apart of related rate, there are a few applications of differentiation. Okay, first, analysis of function 1, which are increase, decrease, and concavity. Okay, the second one will be analysis of function 2, which are relative extrema, first and second derivative test. And then the next one will be apply maximum and minimum problems. And the last one will be rule theorems and mean value theorem.
Next, we continue with the problem statement. This is the problem given. A crane is pulling a brick on a ground with a cable that is attached to a pulley. The pulley is hanging at 10 meters above the ground. If the cable is pulled at a rate of 20 meters per minute, at what rate will the brick be approaching the crane when 125 meters of rope is out? Give your answer in radicals. So now, let's transfer all the information into a diagram. First of all, this is how basically a crane pulling a brick. So, we change the diagram into a right triangle which is consists of the adjacent A, hypotenuse X, and opposite as H. B will represent the brick, C will represent the crane, and P will represent the pulley. In the problem statement, it said that the pulley is above the ground at 10 meters. So, the opposite will be 10 meters. Then, the cable is pulled through the pulley, which is the hypotenuse, at rate 20 meters per minute. So, we label it as dH per dt equal to 20 meters per minute. And the question is, what will be the rate of the brick approaching the crane if the rope out is 125 meters? So, this is happen at the adjacent, so we write it as dA per dt. So, this is the interpretation of the problem statement. We proceed to the objective of this assessment. First, to study the meaning of the related rate. Second, to study the application of related rate. And lastly, to solve the problem given.
We can transfer all the information given from the question into this diagram, where P represent pulley, C represent the crane, B represent the brake, and X here represent the length of the rope. So we already know that the XCT is equal to 20 meter per minute, and we need to find is the ADT. The ADT is the rate of the brake approaching the crane, and the ADT is equal to the ADS multiplied by the XCT. The XCT we already know it is 20 meter per minute, and what we need to find is the ADS. How to find the ADS is by differentiate the value of A with respect to S. The value of A we will get x square minus 10 square from the diagram here by using the Pythagoras theorem method. And when you differentiate the value of A with respect to S, you will get 1/2 bracket x square minus 10 square close bracket the power of negative 1/2 multiplied by 2x. And then the ADS will be 2x over 2 x square minus 100. You make it into the simplest form, and the final the ADS will be x over x square minus 100. And then you already know the ADS and the XCT. You just simply need to put it in the equation after the ADT, and then you substitute the value of x with 125 because the question one when 125 meter of rope is out. When you do that, you will get the ADT is equal to 2500 over 125 square minus 100. And from here you need to change the form into the radicals form, because it is what the question one. How you want to change this form into radicals form is by multiplying this answer with the conjugate of denominator, where the conjugate of denominator is 125 square minus 100. And then you will get this answer when you make it into the simplest form. The final answer of the ADT will be 1569 over 621. If you put this value into the calculator, you will get the exact same value as the value of the ADT here. What we can conclude overall from the video is that number one, the problem to this particular question can be solved by using a related rate method. Number two, any kind of question can be solved easily if the related rate topic was understandably. And lastly, problem has been solved.